Okay, so let's choose a second example of where we look at the first n primes.
Let's say 2 and 3 and 5 and 7.
Well, we don't have to do them in order. Like,
No, what do you want your first? How many primes do you want to have in the set first?
You have 4 primes.
4. So we'll look at 2, 3, 5, and 7.
So you have big 2 and 7 and 3 and 5.
All right. So 2 and 7.
3 and 5.
3 and 5. Okay, that's fine.
So 2 times 7 is 14.
And 3 times 5 is 15.
Okay. So we'll call this A because it's larger than this B.
So, let's see, 14 plus 15 is 29. And then 15 minus 14 is 1.
Okay. So last time we got 5 and 1.
Wasn't it 5 and minus 1?
Yeah, and I'm just saying we'll pick A to be the larger one. So we got 5 and 1 and 29. So anything else you might want to say now?
Well, we have both 1s.
Okay.
But
Maybe we'll always find a 1.
I can see that won't always happen.
Okay, why not?
Because if you choose like 2 and 3
Uh-huh.
and 5 and 7, you have 6 and 35.
Ah, okay.
So that's nowhere close to that.
That's true. Okay, so all right, even though we found 1 both times, we've proven
It's just a coincidence.
that that's just a coincidence. Okay.
And well, they're still both odd. We proved that.
Okay.
Else.
Well,
Do they always differ by 1?
well, no.
Yeah, that's what your brother was just saying. What were the sets you chose
said
instead?
2 and 3 and 5 and 7.
2 and 3 and 5 and 7.
That's 6 and 35.
Give us 6 and 35.
So they don't always differ.
What are the numbers we get there?
So we get 41 and 29.
Okay, so there we've got one that doesn't have a 1 in it. Is there anything else you can say about these numbers?
Well, you could. What would looking at the difference of the numbers do for you? Like, you have 28 and 4. Does that relate to any numbers here?
28.
Well, remember these ones came. Yeah, I actually made it look like I was making a list, which was bad. I should have said 41 and 29 up there. Right, because these ones came from picking 2 and 3. These ones came from arrangements of 2, 3, 5, and 7. So I don't know if you would naturally want to look at the differences because your starting points were very different. So they weren't the same.
So we have n is 4 here.
Yeah, we have n is 4. Do you want to look at another example of n is 4? So we got 2, 3, 5, and 7. You can arrange them.
You can do 2 and 5 and 3 and 7.
2 and 5 and 3 and 7. Okay.
So that's
10 and 21.
Okay, and what are the numbers we get here for A and B?
we have 31 and 11.
Okay. So far, with 2, 3, 5, and 7, and we divide them into 2 groups, we've got 29 and 1, 41, 29, 31 and 1.
Well, I see something
Okay.
here. Then all the numbers in this sequence
Oh.
are either defined to be not prime
Okay.
or prime.
Oh.
So
Okay.
they're either 1 or a prime number.
What do you think about that?
Yeah, that could continue.
So we seem to be getting situations where we're getting a lot of primes.
We have
We started with primes and we're getting
and
primes.
we have 31 and 11 here, but both of them are
But how
prime.
could we prove that?
So
Good. Good. Why don't we go on to the next one?
Alright.